Welcome to today's video. In today's video, we are going to discuss solutions and what affects the solution process. So first of all, let's start at the very beginning and let's look at the parts of a solution. A solution is going to be made up of a solute and a solvent. So what is a solute? Solute is what's being dissolved, and the solvent is what's doing the dissolving. So whenever I started learning about solutions, this was way back in the 9th grade when I took physical science. I knew one was what is going to be dissolved and one is what's doing the dissolving, but I always got them backward. I didn't know how to determine if you're talking about the solute or the solvent, and it was just straight up memorization, and if it went more than a week, I usually forgot it. I had a teacher who said, hey, let me explain it to a way that I think you can remember. And guys, I can remember it this way all the way until today. It's 40 years later. So I want to share this with you, and I don't care if you actually remember it this way, but if it worked for me back then and I've been able to remember it for 40 years, I'm going to share it. So what he did was he just basically said, hey, go through and we're going to use just nothing more than our alphabet to determine which one is what. So write the two words down right beside or right under each other. Solute and solvent. All right, and then go through and see which is the first letter that you get to that's different. And you see that it's the U and the V. Then they simply said, all right, what you want to do is you want to think about a container and you want to think about this right here. So the U is going to be before the alphabet of the V. So it's A, B, C, D, F, G, H, I, K, L, M, N, O, P, Q, R, S, T, U, V. So the U is on top of the V. So the U is going to go into the V. And then they said, listen, all you have to do is think about a simple thing of water and salt. When you take salt and you put it into the water and you stir it up, what's doing the dissolving? The water. What's being dissolved? The salt. So the solute is always going to be dissolved in the solvent. Now guys, like I said, I learned that a long time ago and I've always remembered it that way. So I share that with you. All you really need to make sure that you know is that the solute is what's being dissolved and the solvent is what's doing the dissolving. In chemistry, we have a universal solvent, and the universal solvent is going to be water. A lot of things dissolve in water, and when we get to our properties of water, you'll see why. So let's go through and let's look at a couple of other things, okay? The next thing is we're going to talk about 4 factors that affect the rate of dissolution. So in chemistry, AP chemistry, when I use the word dissolution, what I'm talking about is solute dissolving in a solvent, but primarily the solute is going to be a solid and the solvent is going to be a liquid, usually going to be water. So it's a solid dissolving in water. That is often referred to as dissolution. All right, so we have 4 factors. We have surface area, temperature, pressure, and agitation. So agitation just means you're stirring. So what we need to do is we need to look at these and we need to say, okay, why does each one of those affect it? Well, in order to do that, we come all the way back to last week's class where we were talking about the kinetic theory of matter or the kinetic theory. And basically it says all matter is composed of tiny particles and these tiny particles are in constant motion. So if I have a solid, these particles are so close together that there's no room for them to move around each other. In a liquid, they get further apart. And then in a gas, they're real far apart. Just random energy, random movement. So what happens is, if you look at this, it says surface area. If I'm trying to dissolve something in water and I have a chunk of salt and I drop that whole cube of salt into there, then it takes it a long time because not a lot of it's exposed, just the outer molecules on that salt piece. But what would happen if I put it in a mortar and a pestle? I ground it up into a real fine powder, and then I put it into the liquid. Now I have hundreds of thousands of more molecules being exposed, so therefore it dissolves faster. So if you increase the surface area, you increase the rate of dissolving. So temperature, how does temperature increase it? Well, guys, we come back over here to our picture. Now, the reason that this solid doesn't dissolve anything, the particles you can't get between it. There's not enough space, and they're so structured that you can't squeeze particles in there. But in a liquid, it has more energy, the particles are further apart, and there's room to put stuff in here. Sometimes it's just one particle into space, sometimes it's a whole bunch of them, but whenever you start looking at that spacing and that energy, that is called the kinetic energy. And we said earlier that the kinetic energy, the way that we think about it, is the temperature of the substance. So if the temperature increases, then what happens to the size of the particle between it, or not particles, but the space between the particles? It's called the intermolecular. Yeah, it gets bigger. So you can put more stuff into it. So it dissolves more. What about pressure? What would happen to pressure? Well, anything that affects the size, that space, is going to affect what the rate is for dissolving. So if I start increasing the pressure, and I start with the particles here, the pressure is all around it, and it's pushing the particles closer together. As the particles get closer together, what happens to the space? It gets smaller. So if it gets smaller, you've got less room to actually go through and dissolve stuff. So the solubility is going to go down. And then finally, agitation. Agitation very closely related to the surface area. You're stirring it, and you're stirring it, and you're stirring it. You're rolling it over, and you're exposing more of those molecules. So I wanted to very briefly go through whenever you're dissolving a solid into a liquid, how this is affected and how the kinetic theory of matter is going to explain it. All right, the next thing that I want to do is talk about three types of solutions. So whenever you're talking about three types of solutions, you're talking about whether or not that solvent can dissolve more. If the solvent has some in it, but you can put more in it and it dissolves, then it is said to be unsaturated. If you put and you fill it all the way up, you put one more grain in and it falls to the bottom. You put one more and it falls to the bottom. It is called saturated. And then if you overstuff it, then that is supersaturated. Guys, whenever you start to supersaturate something and it's overstuffed, usually the procedure is going to be that you heat it up, causes the molecules to get more, then you put a bunch of solute into it, and then you let it cool down slowly, and it wraps around, and it holds more than it normally would. You cannot supersaturate a solution or water at room temperature. You always have to heat it up. If you don't heat it up, you just put extra in there, it doesn't dissolve, it just falls to the bottom. So you always heat it up, overstuff it, cool it down, and then you have a supersaturated solution. The last thing that I want to talk about is going to be the phrase likes, dissolve, likes. Okay? So likes, dissolve, likes. So what does that mean? Well, we've been talking about molecular structure. We've been talking about polarity. If something is polar, that means that it has a positive and negative side. Then whether it's a polar covalent or whether it's polar ionic, whether it doesn't matter. If it is polar, if the solvent is polar, then it will dissolve solute that is polar. So likes, dissolve, likes. Take just the flip side of that. If it is nonpolar, Then if my solvent is nonpolar, it's like hexene, which is a very common a very common organic solvent. It's very nonpolar, and you can put nonpolar substances into it, and it dissolves. So likes dissolve likes, and what that refers to is basically the polarity of the substance. All right, so with that being said, I'd like to do a quick little recap. I need for you to make sure that you know what is going to be a solute and what is going to be a solvent. The process of dissolving is often referred to as dissociation. There are 4 factors that affect this dissolving or this dissociation, and they are explained by the kinetic theory of matter. Once you have your solution, you can either have a saturated, unsaturated, or a supersaturated solution. Finally, always remember, likes dissolve likes. All right, I hope that was helpful, and I'll see you in the next video.